Alright, welcome back. Let's start the advanced functional programming section with a cute little topic which is called partial functions. I'm Daniel, let's get right into this. Cool, we're in the IDE, and because we've started a new section, we're also going to create a new package. So here under the source folder, right click and create a new package and call this lectures.part2 Advanced Functional Programming, AFP. We're going to name it lectures.part2 AFP so that the IDE can make the difference between the lectures.part1 Advanced Scala and lectures.part2 AFP. And it will create two folders here, two packages. And for this lecture, in the part2 AFP package that we've just created, we're going to create a new Scala class, and let's just call this partial functions. Make this an object and make it extend app. All right, so our code is runnable. Cool. So by now we should be familiar with functions and function types. So if I say val a function, which is function, which is, let's say, x int arrow x plus 1, this is a function instance of type function1 of int, or an int arrow int as the sugared type. Now, this is what in math and in functional programming we plainly call a function because it's defined on the whole int domain. So any int can be passed to this function and it will return a result. That's key. Any int can be passed and return a result. But sometimes you might want some functions that only accept certain parts of the int domain, say only the values 1, 2, and 5, and for the rest of the int domain, the function should simply not be applicable. So we want our function to not accept any other values other than, in our case, 1, 2, 5. When you write a function, we can't really restrict what value I can pass to it unless I say something like val a fussy function, which is x int arrow, and the implementation should be something like if x equals 1, then I return a value, else if x equals 2, I return another value, else if x equals 5, then I return another value, say 999, else I'm just going to throw a new function not applicable exception or something like that, where we define this function not applicable exception ourselves. So if I say class, this guy extends runtime exception, then this is a perfectly fine fussy function implementation which does not accept any value other than 1, 2, and 5. But I think you'll agree with me that this implementation is a little bit clunky. Now, a slightly less clunky implementation would be to just use pattern matching because it's so fresh in our mind from the previous videos. So if I say val a nicer fussy function equals x int arrow x match, and then I just throw in all the cases here. So case 1, then I return 42, case 2, I return what did I say, 56, and case 3, I just return 999, and nothing else, because if I pass any unacceptable value, this guy will throw a match error, which is still what we want, right? We want this function to just not accept any other value of int other than 1, 2, and 5, okay? Now, this guy right over here, a nicer fussy function, is actually the implementation of a function from the domain 1, 2, and 5 to int. Now, because 1, 2, 5 is a subset of int, this nicer fussy function is called a partial function from int to int because it accepts only a part of the int domain as arguments. Now, Scala supports the partial function types, and a shorthand notation for writing it is a partial function is of type partial function from int to int. So this is the complete type, partial function int, like you would say function 1. And the value here on the right hand side is, and watch what I'm writing, I'm opening a curly brace, and then I'm going to put in the cases here inside. So this guy right over here, in between the curly brace, including the curly braces, is called a partial function value. And it's equivalent to the definition above, as in xint, arrow, xmatch, all these cases. But this is a sweeter shorthand notation. So partial functions, as we see here, will act like proper function in the sense that they can be called and used like any other value. So if I say, for example, print line a partial function called with the argument 2, now remember that this actually invokes the apply member from partial function, and partial function does have an apply method. This will give me the value 56. Right? But if I call a partial function with another number, say 57,000 whatever, then this will crash with a match error, because partial functions are actually based on pattern matching. Okay? Now again, this expression right over here is a partial function literal and is equivalent in implementation with the implementation here above with the total function. The difference is that this literal here is a partial function and is only assignable to a partial function, whereas this guy is a proper function and it cannot be assigned to a partial function because it is a total function. Cool. Now that we know what partial functions are and how they work, let's talk about some utilities for partial functions. I just commented out this little piece because it would crash my program. So, partial function utilities. If I print line, for example, a partial function dot is defined at, let's say 67, then this guy will test if a partial function is applicable for these arguments. This is a very useful test that will figure out if a partial function can actually be run with these arguments instead of me actually applying it with the wrong arguments and crashing my program. So this guy in particular will return false. Now, partial functions can be lifted to total functions returning options, because if a partial function is not defined for a given argument, it will just return none. So for example, if I say val lifted equals a partial function dot lift, this will turn a partial function from int to int into a total function from int to option int. And if I print line lifted with the argument 2, I should be seeing the value 56. But if I call lifted with the argument, I don't know, 98, I should be seeing none. So this guy will return some with 56, and this guy will return none. So let's just run this real quick to prove it. Okay, so we see some 56 and none. So this is a useful method that will transform a partial function into something that will not blow in your face if you call it with the wrong arguments. There's also or else if you want to chain multiple partial functions. So if I say a chain, partial function chain equals a partial function dot or else with int, or else takes 2 type arguments, and I'm putting in a case, let's say 45 error 67. So or else takes another partial function as argument, and the partial function that I'm providing here is case 45. So basically, if I print line pf chain with the argument 2, I'm still going to get 56 because it originates from the first partial function. But if I print line pf chain with 45, that's not an argument from a partial function, from the original partial function, but it's an argument for the second partial function, which this guy will fall back to. So I'm going to see 67 in my console. So if I run this real quick, we see 56 and 67. Now, also useful to know is that partial functions can be attributed to something declared to be a total function. So basically, partial functions extend normal functions. So if I say val a function, which is of type int arrow int, and I'm going to say case 1, let's say 99, let's call this a total function. Okay, now a total function being declared as int arrow int, I can actually supply a partial function literal from int to int, because partial functions are a subtype of total function. Now, a side effect to that is that our favorite higher order functions accept partial functions as well. So if I say list, let's say val a mapped list equals list 1, 2, 3, and then map with the little syntax sugar that we talked about a couple of videos ago, and as an argument I'm going to supply, instead of a total function, I'm going to supply a partial function and say case 1, say 42, case 2, 78, and case 3, 1000. All right, so this is an acceptable expression. So if I try to print this out, I should see 42, 78, and 1000 in a list. Okay, so list 42, 78, and 1000. But if I say case 5 instead of case 3, then the number 3 here will crash because the map function will attempt to apply this guy to the number 3, and it will crash with a match error. See? Because the number 3 is not part of our cases here. So I'm just going to undo this and make our program run again. Cool, so we've learned quite a bit. Now I want to put in a small note here. Unlike functions, which can have multiple parameters, a partial function can only have one parameter type. So partial functions can only have one parameter type. And it makes sense. How otherwise would we implement a partial function with multiple parameters with pattern matching? How would you pattern match with multiple parameters? All right, so keep that in mind. Cool. Before we wrap up, I want you to do a couple of small exercises. They're very easy. The first exercise is that I want you to construct a partial function instance yourself by instantiating the partial function trait on the spot, so with anonymous class. All right. Then I want you to implement a small dumb chatbot. As a partial function. So here's how it will work. Exercise number 1 will ask you to construct a partial function instance by instantiating an anonymous class which derives from partial function. If you have any need for inspiration, you can define a fuzzy function by instead of providing the partial function literal, I want you to create an anonymous instance of the partial function trait and actually implement the required methods on the spot, just to get a sense of how you would otherwise instantiate partial functions without the Scala syntax sugar here. All right, so this is exercise number 1. So exercise number 2, how does this work? Well, the idea here is that you would write things in the console, so you would start the console, and you would write things into the console, and with each line that you write in, you pass it to the chatbot, and the chatbot would reply with a message. And the chatbot would have only a limited number of potential answers to your queries, all right? The way that you would write things to the console or read things to the console would be to say scala.io.source.stdin, which is for standard input, get lines for each, and then you would pass the line to the chatbot and then process it and then print back the reply. Now I'm just going to provide you with an example that just prints the line back to you. So if I say line arrow, print line, you said, colon, plus line. Okay, so if I right click and run this, the program is still running, and if I say hello and enter, the program said you said hello because this guy is still in effect. So basically what I would need you to modify is this little function here, where for each line you pass it to the chatbot and you print line the chatbot's response. All right, so take a second to think about this. The exercises should be really easy. Pause the video and I'll come back with solutions in just a few moments. All right, so the exercises here are really easy. Now, if you wanted to construct a partial function yourself, you would need to write, let's say, a manual fussy function, which is a new partial function from int to int, and then just implement the required methods on the spot. And the required methods are, say, override, and we need to override apply, and we need to override is defined at. These are the characteristic functions of partial functions. These are the characteristic methods, to be very precise. So is defined at, saying is the partial function defined for this given argument, and the result is going to be x equals 1 or x equals 2 or x equals 5, just to follow the example from the fussy function we defined at the beginning. And at the apply, we're just going to say x match or v1 or whatever. Let's call this x match, case 1 arrow 42, case 2 arrow whatever 65 or whatever we wrote in there, and case 5 equals 999. Okay, so this is how you would otherwise define a partial function if it hadn't been for the cute syntactic sugar, where you did not need to write all this boilerplate. All right, so by writing these things ourselves, we get to appreciate the syntax sugar that Scala provides for us. Okay, so this was very easy. Exercise number 2 with the chatbot is also very easy. So if I say val chatbot, this is simply a partial function from string to string, the argument being the query from me and this guy being its response. And I could just say, okay, in case I say hello, the chatbot will reply saying, hi, my name is Hal9000. If I say case goodbye, the chatbot will say, once you start talking to me, there is no return human. Something like that. In case call mom, the chatbot will say, unable to find your phone without your credit card, or something like that. Okay, and you can play with this chatbot as you want. And if you want to modify this little call over here to process each line by passing it to the chatbot, you could say print line and say chatbot says chatbot line. This is how you actually apply the partial function. So if I right click and run this, then the program is still running, and if I say hello, And if I hit enter, the chatbot says, hi, my name is Hal9000, because chatbot is applied to the line that I pass in here, and the line matches the string hello. So it says, hi, my name is Hal9000. And if I put in some value that he does not understand, like get out, this thing will crash because chatbot with the line will not match its predefined inputs. All right. Now, before I wrap up, just a little bit of a refactor just to make this a little nicer. So this guy is the stream of lines that I write here at the console. And instead of saying for each, I could actually map it with chatbot. So basically I say chatbot says, okay, and then I for each print line. Okay, dot for each, of course. So for all the lines that I write, I map them to the chatbot. So I put them through the chatbot partial function, and the responses from the chatbot, I print them out to the console. So if I right click and run this again, I should be seeing much the same thing without the little chatbot says prefix here. So if I say hello, the chatbot will say, hi, my name is Hal9000. If I say goodbye, the chatbot replies, once you start talking to me, there is no return human. Uh-oh. And if I crash, this thing will crash again because I'm out of the chatbot's league because it doesn't contain this crash in its list of predefined inputs. All right, so these are the exercises. All right, so what have we learned? We discovered partial functions as things which can take as parameters only a subset of a given domain. We've learned how to use them as partial function literals, which run on pattern matching. We've also seen a number of utilities that allow us to see if a partial function is defined on a given argument before it blows up in our face, a way to turn a partial function into a total function, and a way to compose partial functions. Partial functions are actually used in practice on other types as well, especially in collections with map and collect and others, and recover on other computational types such as try or future. All right, so quite an important topic. I'm sure you're going to see quite a lot of partial functions in production code. I'm Daniel. I hope you found this video useful, and I'm waiting for you in the next video.